Now let's take some questions on the basis of what we have done till now. Let's say question 1. So till now what we have done is we have done trigonometric ratios. They are also, in short, they are called T ratios. T ratios means trigonometric ratios. Alright. And what do you mean by trigonometric ratios? Trigonometric ratios mean sine, cos, tan, and then their inverse. Sine inverse will be cosec, cos inverse will be sec, and tan inverse will be cot. So there are 6 total trigonometric ratios. Now the idea is that if one ratio is given, you can find the other ratios also for that angle. Okay, so let's take question 1. If we say, let's say cos theta is equal to 8 by 17. The question is find other trigonometric ratios, or we could have simply said T ratios, other trigonometric ratios for angle theta. Right? So for angle theta, one of the trigonometric ratio, that is cos theta, it is given. Find all the other trigonometric ratios for theta. That means we will need to find sine theta, we need to find tan theta, we need to find sec theta, cosec theta, as well as cot theta. Right? Now there are 2 ways of doing this question. Alright, so first let's take method 1. Method 1 is the formula method. Herein we only use the formulae. Okay, formula method. How do we do that? We have done only 2 types of relation. One is the ratio inverse, right? And the other one that we have done is the square relations. Okay, we'll use only these 2. So in this method 1, let's say already cos theta is given. So cos theta is equal to 8 by 17. From there straight away, sec theta will be equal to inverse of cos theta. So 1 by cos theta, which is inverse of cos theta, that is 17 by 8. So one of the other trigonometric ratios we already have got. Now we also have a formula, sine square theta plus cos square theta from square relations, that is equal to 1. So from here we can see that sine square theta is equal to 1 minus cos square theta. So that means sine theta will be equal to square root of 1 minus cos theta, right? 1 minus cos square theta. Now cos theta value is given 8 by 17. Put it here. So sine theta will be equal to square root of 1 minus 8 by 17 whole square. Calculate it normally. It will be square root of 1 minus 64 upon 289. Take LCM. It will become root of, in denominator 289, and numerator will be 289 minus 64. So it is root of 225 upon 289. Now 225 square of 15 and 289 square of 17. So it is 15 by 17. So what do we get? We get sine theta value here. So I'll use this space. So we already have cos theta, that is equal to 8 by 17. We have just calculated sine theta, that is equal to 15 by 17. We also know from the ratio formula that tan theta is equal to sine theta divided by cos theta. Now here sine theta is 15 by 17. Cos theta was already given 8 by 17. So what happens? 17 and 17 get cancelled and we'll get 15 by 8. Right? Now inverse of sine theta will be the cosec theta. So cosec theta is equal to inverse of sine theta, that is 17 by 15. And from tan theta, we already have tan theta equal to 15 by 8. So inverse of this, that is cot theta, will be equal to 1 by tan theta, that is 8 by 15. So as you can see, now we have calculated all of them. From cos theta, we directly calculated sec theta. From square relation, we calculated sine theta. Then by taking ratio of sine theta and cos theta, we calculated tan theta. By inversing sine theta, we get cosec theta, and by inversing tan theta, we get cot theta. So this is one method wherein we use the formula. Alright, there is another way of doing the same question. Let's take up. Now let's take up the second method, method 2 of this question. Now method 2 is also called the right angle triangle method. Okay, right angle triangle method. What we do in this, that we initially we draw a right angle triangle and we assign one of the angles as theta. So let's say this triangle was ABC and let's say this angle is theta. Now in this triangle, for this angle theta, cos theta will be defined as The ratio of adjacent is to hypotenuse. Now adjacent side here it is BC and hypotenuse is AC, and the value of cos theta is given 8 by 17. So we say that BC upon AC is equal to 8 by 17. So very safely we can take the value of BC as 8 and AC as 17. So BC as 8, AC as 17. Now using Pythagoras theorem, that is AB square plus BC square is equal to AC square. From here we can calculate AB square, that is equal to AC square minus BC square. We have taken the value of AC as 17, so 17 square. BC as 8, so 8 square. 17 square is 289, right? So AB square is equal to 289 minus 64, which is equal to 225, which is 15 square. So we get AB equal to 15. So if I put AB equal to 15 here, now we have the values of all the three sides. Using the values of all the three sides, we can find every other trigonometric ratio. For example, for this angle theta, let's say sine theta. Now what will be sine theta? Sine theta will be opposite upon hypotenuse. Opposite side is 15, hypotenuse is 17. Inverse of sine will be cosec theta. So cosec theta is straight away from here 17 by 15. Similarly, tan theta can be calculated as opposite upon adjacent. Opposite side is 15, adjacent side is 8. From here we can inverse and we can get the cot theta value, that is 8 by 15. And from cos theta only, cos theta was already given, cos theta is 8 by 17. So from there itself we can calculate sec theta as inverse of cos theta, that is 17 by 8. So there are two different ways of calculation of other trigonometric ratios for a given angle. One is the formula method, and the other method is the method based on the right angle triangle. All right, let's take one more question on this. Now let's take up the second question. It says if sec x plus tan x is equal to 5, find all trigonometric ratios for angle x. Right, so it's given that sec x plus tan x is equal to 5. And we have to find all the trigonometric ratio. That means we have to find sin x, cos x, sec x, cosec x, tan x and cot x, right? So what should we do? There is a square relation that we had done. As sec square x minus tan square x equal to 1. Now look at this closely. It is a square minus b square, and we know that there is a formula for a square minus b square which says it is equal to a minus b into a plus b. We can apply that formula here. Okay, this will look like, this can be taken as sec x minus tan x into sec x plus tan x, that is equal to 1. From here you can see that sec x minus tan x is equal to 1 divided by sec x plus tan x. Now we also have sec x plus tan x as 5. So 1 by sec x plus tan x will be 1 by 5. So what we have here is sec x minus tan x is equal to 1 by 5. Right? Let's write these two equations together. We already have sec x plus tan x equal to 5. And we take sec x minus tan x is equal to 1 by 5. Alright. So, if you simply add these two equations, let's see what happens. If you simply add, tan x and tan x will get cancelled. Sec x plus sec x will be 2 sec x. And it is equal to 5 plus 1 by 5. In denominator, LCM 5 5s are 25 plus 1, that is 26 by 5. Okay, so this is 2 sec x is equal to 26 by 5. So if you divide by 2, you get sec x is equal to, from here you get sec x is equal to 13 by 5, right? So from there you can directly see that cos x will be inverse of that, that is 5 by 13. From here itself we can find the other ratios, okay? Or what you can also do is you can go back here and subtract. So I'll write those two equations again. Sec x plus tan x equal to 5. Sec x minus tan x equal to 1 by 5. And now you subtract. So if you subtract, what will happen? This becomes minus, this becomes plus. Sec x and sec x get cancelled. Tan x plus tan x is 2 tan x. That is equal to 5 minus 1 by 5. Now 5 minus 1 by 5, take LCM 5. In the numerator we will have 5 5s are 25 minus 1. That is 24 by 5. So what do we have? 2 tan x equal to 24 by 5. From here you get tan x equal to 12 by 5, right? If you inverse, you will get cot x equal to 5 by 12. Okay. So what all do we have now? We have sec x, we have cos x, we have tan x, and we have cot x. We still have to find sin x and cosec x. Let's do one thing. We know that tan x is equal to sin x upon cos x. From there, you can see that sin x actually is equal to, by cross multiplication, it is tan x into cos x. So tan x value, here it is 12 by 5. Okay. Cos x value, we have already calculated, it is 5 by 13. So if you put here, 5 and 5 get cancelled and we have 12 by 13. Perfect. So what do we have now? We have sin x is equal to 12 by 13. And by taking inverse of that, we have cosec x, which is equal to 13 by 12. Right? So we have calculated all the trigonometric ratios for x. Okay.